Hello, PreCalculus students. This is Mr. Gross bringing you lesson 1.7, Piecewise Functions. Now in today's lesson, we are going to learn about piecewise functions, and a quick definition, as you can see right here in front of us. A piecewise function is a function in which different equations are used for different intervals of the domain. Okay, so that seems maybe a little bit confusing. Different functions in which a different equation is used for different intervals. So, what does that mean? Well, if we take a look at an example, I think it would be the best way to explain exactly what a piecewise function is. So, as you can see in the example, we have graph f of x equals, and then we have a brace, and then we have three different lines of equations. Okay, so each of these have different parts. So let me kind of break these up a little bit. So here's the first part. 1, if x is less than or equal to negative 2x. The second part, 2 plus x if x is between negative 2 and 3. And the third part is 2x if x is greater than 3. So maybe a better definition of a piecewise function, it's basically a graph that is broken up into pieces. So what we have here is we have three pieces of a graph. Now we're going to still graph f of x. Okay, so f of x is still going to be the end result. So we'll have one graph that it'll be in three different pieces. And the three different pieces that we're going to draw are the blue, the green, and the red. And all those together would make the purple f of x. All right? So how do you graph a piece of a function? Well, the easiest way that I believe is to make a table. Okay, so we're going to make a table for each piece of this function. So let's start with the blue piece. Okay, so we have an x and we have a y. Now, y is going to be equal to whatever part is on the front half of our circled area. So if I draw a little line here right where the if is, okay, that kind of splits this up. So you can see in front of the black line we have the number 1. That's the actual function, 1. Okay, and then for the green table, we have x, then y would equal 2 plus x. And then for the red function, we have x, and we have y equals 2x. So whatever is in front of the if, okay, is the function, that piece of the function. So that's what y is equal to, whatever's in front of the if. Now, what is after the if, okay, are some intervals. And those intervals tell us what numbers we're allowed to plug into the tables. So for the first blue part, you can see here that we have x is less than or equal to negative 2. So I'm going to plug in things that are less than or equal to negative 2. So we'll start at negative 2, so we go like negative 2, negative 3, negative 4, and so on. It'll continue on forever. All right? And then for the green part says that we're going to plug in x's between negative 2 and 3. Now, even though negative 2 only has a less than sign, we will still include it. But we will have to do something special with that before we're ready to graph. But we will include negative 2. So negative 2. And it's between negative 2 and 3, so we're actually going to go larger. So negative 2, negative 1, 0, 1, 2, and 3. Okay, now for the red, what x's are we allowed to plug in? We're allowed to plug in x is greater than 3. Now again, if 3 shows up in the interval, we are going to include it in the table. So we're going to start with 3, and we're going to go larger. So 3, 4, 5, and so on forever. All right, so now we just have to plug in the x values and get some results. So we'll go back over here to the blue equation, and we're going to plug in -2 for x in the equation at y equals 1. Now, since there are no x values, that means no matter what value of x we plug in, we're always going to get the result of 1. I plug in -3, 1. Plug in -4, 1, and so forth, forever. And these create points. Okay, these are all points on the graph of f of x. Okay, so there's the blue part of f of x. And in the green part, we're going to create some points as well. So we plug -2 in for x. When we do that, we get 2 plus a -2. So that's 0. We plug -1 in for x. That's a really bad 0. Let me fix that. So 0. Now if we plug -1 in for x, we get 1. Plug in 0, we get 2. Plug in 1, we get 3, because it's even worse. 3. Let's try that again. This 3 is just not working. Okay. We plug in 2. 2 plus 2 is 4. Plug in 3. 2 plus 3 is 5. All right, so again, we have these points. And then for the red, we plug these in for x. So 3 in for x is 2 times 3, which is 6. 4 times 2, which is 8. And 5 times 2, which is 10. And that continues forever. Okay, so now the only thing we really have to be careful about before we graph this is that the couple of numbers that did not have an inequality with it. So right here, I'm circling in black. You can see that -2 only has a less than sign, and 3 has only a greater than sign attached to it. Now the -2 is less than or equal to, that's fine, and the 3 is less than or equal to, that's fine. Now it doesn't matter if it's greater than or less than, it's the equal to part that's important. So if you have a number, okay, that is attached to a less than without an equal sign, or a greater than without an equal sign, those dots, when you graph them, are going to be very special points. They're going to be open dot points. Okay? So -2, 0, I'm going to circle this because that's going to be an open dot when I graph that. And 3, 6 is going to be an open dot. Now all the other points are okay because everything else is equal to. Alright? Just the ones that are attached to the inequality and does not have an equal to sign are open dots. Okay, so now that we have these tables, we can draw our graph. So you're going to go -4 to 5, and then we're going to go up to 10, so let's do this. This is going to look a lot better on graph paper. So if you could, please do this with graph paper. It's going to look a lot better. So let me go ahead and switch back to blue. We're going to graph the blue part first. So these are all going to be solid dots because it's less than or equal to. So all solid dots when I plot these. So -2, 1, -3, 1, and -4, 1. solid dots. We'll make them big old dots here. Now, we're going to connect those up and continue the pattern forever. So as you can see, since this is being drawn forever, the end of our graph is going to be drawn forever also. Okay, so that part is going to, the graph is going to go to the left forever. Okay, so now the green. So open dot, okay, on -2, 0. It's going to be the only open dot, -2, 0, open. All the rest will be solid. So -1, 1. 0, 2. 1, 3. 2, 4. Some trouble with this. 3, 5. These are all solid dots. Try something else. Alright, sorry about that. I had a little difficulty with the dots here. So we're just going to try to make them here like that. So now we're going to connect those up. The straight line. Straight of a line as you can make. Alright, so that's the second piece. Notice that they are not connected. Okay? Not connected. That's okay. They don't have to be connected. Okay? We're just going to graph the pieces as we are given them. Okay, and the last part. So 3, 6 is going to be an open dot. 4, 8, and 5, 10 will be solid. I'm going to connect those up. And again, try to use graph paper on this. This is a very rough sketch. It's going to look a lot better on graph paper. So we have open dot, break. We have a break in the graph between the blue and the green. We have a break in the graph between the green and the red. Alright? And that's how a piecewise function works. Okay, so you're just going to draw the pieces as you make the tables. This entire graph, this whole thing, is f of x. Alright, here's another special function. Okay, so the piecewise function is one type that you're going to have to draw. Another one is the greatest integer function. Now we have a very special symbol. It's like a double bracket with x in the middle. And this means the greatest integer not greater than x. Alright, now give you a little heads up on this. This is actually a test question. On the next test, one of the questions will ask you to graph the greatest integer function from memory. No tricks, straight up graph it. Okay, so let's draw a sketch of the greatest integer function. Okay, it's looking a lot better probably with graph paper. And so we have to interpret what exactly is the greatest integer function. So we can plug any value of x in, all right? And what happens is when we do that, it's going to put out, as the definition says, the greatest integer that's not greater than x. All right, so if I plug the 0 in, well, 0 is just 0. So we plot that. At the greatest integer not greater than x. Okay, well, 0, that's fine. But if I plugged in 1, well, 1 would actually, again, be 1. So how are we going to graph this? It's a little bit confusing. Okay, so we plot 0. Let's think about decimals here. If I put in 0.1, well, we want the greatest integer not greater than 0.1. Well, the greatest integer not greater than 0.1 would be 0. And if we did 0.2, 0.3, 0.4, 0.5, all the way up to 0.9, or 0.9999999 forever, okay, those would all be going back to 0, because 0 would be the greatest integer not greater than that number. So 0.90 would be the greatest integer that's not greater than that. But what happens when you hit 1? When you hit 1, it jumps up. So here's how the greatest integer function looks. It actually looks like a step function. So it's going to be a solid dot at 0 and an open dot at 1. And then we're going to have a solid dot at 1 and then an open dot at 2. And we step up 1, put a solid dot at 2, and an open dot at 3. And remember, it's going to be flat the whole time. So for instance, if I picked 2.5, so if I put 2.5 in, I'll put it up here, 2.5, that would result in a 2. 2 would be the greatest integer not greater than 2.5. That pattern would just continue. So when we get to 3, it would jump up and hit 3, stay flat until we hit 4, open dot at 4, jump up 1, solid dot, and just keep going. All right, now, same thing, we go in a negative direction. So kind of go backwards here, so I can put an open dot here at 0, and then solid dot at -1. Connect those up, jump down, open dot, solid dot at -2. Connect those up. Okay, open dot at -3, solid dot, and so forth. Okay, so you just need to draw this. Step function is another word for it, okay, because it looks like steps. Okay, the step function. As you see this is exactly how you need to graph it on the test. Okay, so draw a nice graph on a graph paper. We'll go over it the next day, and we will. This is the exact question that's going to be on the test. All you need to know is the greatest integer function. Okay, the next special function that we're going to take a look at is the absolute value function. So as you can see, I have the absolute value of x drawn here. So if we plugged in some values, if we put in 0, I guess I don't have 0, 0 marked, but if you put 0 in, the absolute value of 0 would be 0. If you put in 1, well, the absolute value of 1 is just 1, it doesn't change. 2 is 2, 3 is 3, and 4 is 4, and so forth. Where it does change is that the negatives. Okay, so if I put a negative 1 into an absolute value bar, I would get a positive 1 out of it. That's why the y values are all positive. So this is a graph is a V. All right, it actually looks like a V. It's not a parabola. It's not curved. It's a straight line right into 0 and then straight line out of it. Now the absolute value function can be written as a piecewise function. It can be written in two pieces. Okay, so as you can see here, if negative x, if x is less than 0, which makes sense. So if you're plugging in a negative number, right, that's what x less than 0 would be, a negative number. Well, to make it positive, you put a negative on. And if you have a positive number, you don't have to do anything to it. You just leave it alone. That is the result. Okay, so let's graph a absolute value. So again, you can make a chart. This is a piecewise function. We're not going to write it as a piecewise, but in order to graph this, I would highly suggest making a chart. Okay, so we're going to make an XY chart. X and my Y is 2 absolute value of x minus 6. Now, on a regular absolute value function, the point of the V was at 0. So how do we know where the point of the V is going to be for any absolute value function? Well, that's actually quite simple. To figure out where the point of the V is going to be, you will take what is inside the absolute value, which is just x, okay, and set it equal to 0. And that tells you what it's going to be. So if it's just a plain old x inside the absolute value, the tip of the V is still going to be at 0. So how do we do that with our chart? Well, the tip of the V has some graph to the left and to the right of that. It's more like the middle of the graph. So we're going to put that value of x, 0, right in the middle of our chart. And we're going to do a couple negative, so negative 1, negative 2, which would be left of the V, and a couple positive, 1 and 2, which would be to the right of the V. And then we're going to plug this in. So we have, I'll write this out, so we have 2 times negative 2 absolute value minus 6, or we end up with 2 times 2 minus 6, which is 4 minus 6, or negative 2. We plug in negative 1. We get 2 times 1 minus 6. I don't think we need to write that out. 2 times 1 minus 6 would be negative 5. Right? No, that's not right. Maybe we should write this out. 2 times negative 1 minus 6 is going to be 2 minus 6, or negative 4. We plug in 0. We will get 0 minus 6, or negative 6. Plug in 1. We get 2 times 1, or 2. 2 minus 6 is going to be negative 4. And 2 in fracts. 2 times 2 is 4. So 4 minus 6, we get negative 2. So our points are negative 2, negative 2, negative 1, negative 4, 0, negative 6, and 1, negative 4. Oh, there's one more. And 2, negative 6. Sorry, 2, negative 2. Alright, so we're just going to plot those points. Alright, so negative 2, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, so negative 2, negative 2. Negative 1, negative 4. 0, negative 6, 1, negative 4, oops, put that at 5, put that at 6. All right. So 1, negative 4, and 2, negative 2. So you can see where the tip of the V is. Connect this up with a straight line, straight as you can make it. Ruler would be very helpful in doing this, making these straight. I can cheat a little bit. I actually have a line function here. That looks much better. Okay, so there's our absolute value graph. So again, the key is finding where the tip of the V would be by setting whatever is inside the absolute value equal to 0. Okay, so that's all we have for today.